Hi all, this is Junaid here from Edureka and I welcome you all to this session where we'll be talking about image processing using Python. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding what exactly is image processing and why do we need it. Moving ahead, I'll be speaking about how Python can be used for computer vision. Finally, we'll end this session by walking through some of the fundamental concepts that revolve around computer vision, and then we shall see how we can implement it by building an application that recognizes handwritten characters. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking for online training certification in Python, check out the link given in the description box below. Alright, to start off now, what exactly is image processing, right? Well, image processing is a method to perform some operation on an image. This is done in order to get an enhanced image or to enhance some useful information from it. Well, you can say this is a type of signal processing in which input is actually an image and output can also be an image or a characteristics or a feature that is associated with that particular image. But why do we need image processing, right? Well, we all know nowadays image processing is among the rapidly growing technologies. It forms a core research area within the engineering and computer science discipline. You see, image processing is used in various fields. As you can see here, we can use image processing to track human behavior and their positions. This can further be used to develop games or any kind of security task. The another popular use case of image processing is driverless cars. We all are the witness to this. You see, driverless cars are one of the most coolest piece of technology that exists today. And the top players when it comes to driverless cars are like Tesla, Audi, Mercedes, and many more. Moving on to the last but not least application, that is implementing image processing in medical images. You see, we can use this X-ray, CT scan, or MRI to find abnormalities. You see, if a person has a kind of a fracture or a cancer that is being detected in using an MRI, we can actually compare that particular image with respect to the other set of image which does not have or which are totally normal. And then based on certain criteria and by applying that to a deep learning model, we can figure out whether there is any abnormalities that are present there. But you see, we cannot use the output or whatever the opinion given out by a machine learning algorithm. This is always treated as a third opinion or something that we can show it to a patient that so and so place has so and so issues. Alright, so now that we know the motivation behind image processing, I'm sure now you might be wondering, how can I work with image processing, right? Well, you see, we have various number of programming languages and frameworks to work with. But one of the popular approach is by using Python. You see, Python has many built-in libraries and tools with which we can not only perform actions on these images like thresholding, augmentation, or whatever it is, but we can also process the images using deep learning or machine learning algorithms to perform classification operations. Some of the popular frameworks or libraries here are OpenCV, PyTorch, then we have TensorFlow, NumPy, and many more. Alright, now that we have a brief intuition about image processing, let's see some of the fundamental concepts that revolves around this. One of the most fundamental concepts in image processing is image filters. You see, in image processing, filters are mainly used to suppress either the high frequencies in the image, that is by smoothing an image, or by lowering the frequency, that is by enhancing or detecting the edges in that particular image. An image can be filtered either by using a frequency domain or in a spatial domain. Speaking about frequency domain, it involves transforming that particular image into a frequency domain. Multiply that frequency with a frequency filter, and then again, once that's done, retransforming the result into a spatial domain. We say spatial domain is nothing but a matrix. The other way to filter our image is by using a kernel. Kernel, or it can also be referred to as a filter, can be used to extract any information from this. Some of the popular filters that are there is mean filter, then we have mode filter, maximum filter, minimum filter, Gaussian filters, and many more. The way this works is that we have an image which is present in a spatial domain, and this particular kernel just moves over it. And this is what is happening here. As you can see here, we have our image. Okay, so this particular thing is our image, and this is what we said as a kernel. Okay, we can say a kernel or a filter. And this is basically here what we're using is, a filter. And every time this filter goes through all of these points of the spatial domain, you can see here it gives us certain values. So this is how a filtering works. All right. So then in the next component, if we move ahead, we have something called as padding. Okay. So as I have mentioned, we will be using, a filter, right? So let me quickly show you that. So this thing over here is a filter. and this is our image. But as this filter moves through this image, that is across this 3x3 grid, most of the time what happens is, our image gets cropped. And when an image gets cropped, that is this particular pixels, these get cropped. And when an image gets cropped, what happened is most of the features are lost. Like what if there is an important feature which is present at this edge, right? So this would actually crop the image. So in order to prevent that, we'll add some extra layer of pixels. With this, what happens is, all of these external layers will be included in our final transformation. All right. So this is exactly why we use padding. Basically, we use padding in order to remove or in order to reduce the loss of information from our image. Moving ahead to the next concept, that is thresholding. You see, thresholding is a type of image segmentation. What happens over here is, like, when I say image segmentation, as the name suggests here, segmenting means basically to separate, right? So here we have an image, okay, and this is basically, it can be a colored image or an RGB image. And then we all know that images is basically a pixel values, right? They are the grid of pixels, and the pixel value of an image can range from 0 to 255. 0 typically means it is a black image, and 255 means it is a white pixel. So what we do in image thresholding is that we set a particular threshold value. You say, something like we have like somewhere midway around, right? We come down and we set a threshold value, and whatever value that lies below this threshold, we say this is like to replace that pixel with either 1 or 0. That is nothing but either it can be a black or white, and whatever the value which is there on the other side, will take the alternate value here. And so what happens in the resulting thing is we have a blob which is formed here. All right. So as you can see here, we have a man who's taking a he's trying to record something over here. Now, once we are done performing thresholding, you can see the image has been converted to now black and white. So with this, what happens is it becomes easier to extract noise and also to scan for any abnormalities. Moving ahead to the next topic, that is connected components. Now that we know what does this image thresholding does, right? So it's basically, like either the value can be 1 or 0. So now what happens is we have to process our image, right? So this particular part or this particular image over here is nothing but thresholded image. So here, whatever the values were there has been converted to either ones or zeros. But now this is still of no use for us. So this is where the connected components come in. So whenever there is the continuous structure of pixels, right? Like as you can see here, this guy's hand, this is one continuous row of pixels. Then we have, you can see the other hand, but there is a small white pixel area which is present here, right? So if there is a small bridge or there's a small gap here, that means those two are two different components. That's why when I perform this connected components, you can see here this right arm of this guy and a laptop are considered as one, because there is no pixel gap between them. With this, what happens is, we can perform analysis over here. We can say this is the guy's head, and then we have earphones, and then mostly we can whatever this image, whatever this output we have, we can mask it on an original image to get a better understanding of what are the things we are trying to detect. And we can also perform various operations like such as building a bounding box. We can get this particular value here, and this will just create a bounding box around this. And like, let me just change the pen color here. Okay, if I take up this green, so this particular thing will create a bounding box by taking the maximum and minimum value of this coordinates, and then we can detect this particular part here. So this is exactly why we perform image thresholding, and then we see what are the various continuity in the pixels that we have, so that we can see various different dimensions in an image. Alright, so now that we have a basic understanding of what exactly is image processing, let's now move ahead and let me show you how we can implement whatever we have learned into a form of an application. Alright, so for this, let me quickly move to my code editor here, and the code editor that I would be using is Visual Studio Code. Alright, so let me quickly set our directory here. Alright, so now that we are here, what I'm going to do is we are going to perform this operation in 2 stages. So let me quickly take up this. Let me go to my paint. So let me tell you what I'm doing here exactly. Okay, so first thing is we have to create a model. So what this model does is this model will take in multiple images. Okay, this model will have multiple images, and we'll train this model on MNIST data. So MNIST data is basically a set of handwritten digits. And this model, this would be basically on a deep learning model that we are going to create on our own. And the way this works is once we train this model, whatever input image I provide, which the size would be 28,28, it will give me a correct prediction what that image exactly is doing. Okay, this is stage one. And the second stage is we have to, whatever model we have created, we'll create .h5 file for this so that we can use this in our application. Now what happens in our application is, so let me show you what we'll be doing here. So we'll create a board, something like this. Okay, and inside this board, anytime like you take up any handwritten image and you press 9, what happens is we will get a bounding box which will detect this particular number, that is 9, and give me an output over here. All right, and if I write 8, it will just detect this and give me a number 8, and all of this will be happening in real time. Okay, so this sounds pretty interesting. So let us now quickly start working on this. So first off, we would be needing a Jupyter notebook, right, to train our model. So what I'm gonna do is, in this folder, I have a couple of images here. This images is nothing but MNIST image. So as you can see here, this is a small image. It's a 7, and then if I put like 5, okay, so this image represents 3. So this is basically a small data set which I have done. And now inside this, we'll train a model. So let's quickly get that done. So to open a Jupyter notebook here, we just need to press Ctrl Alt P. All right, and now we just hit that, and now finally we'll save this. All right, so now we are supposed to train this particular model, right? So what I'm gonna do here is we'll first try saving this up. So I'll save this inside this model development, and I'll just give a name here as model development, and we'll save this up. All right, and now, all right guys, so now that we are here at our Jupyter notebook, first off we have to install a couple of dependencies, right? So in order to install, I don't have to actually go back to my Anaconda command prompt and type. So we have the simple shortcut. What we can do is we can put an exclamatory mark and type pip install keras. Okay, and then we can also do similarly for pip install sklearn, and let's execute this. All right guys, so as you can see here, we have successfully installed keras in our Jupyter notebook. This would usually take time depending upon your internet speed. All right, so let me quickly import keras now. So we have from keras dot dataset import MNIST data, right? And then a couple more things that I would be needing is like numpy, import numpy as np, and then at the same time we'll also use mat.lib. Import mat.lib dot pyplot as plt. All right, so the reason why I was having this issue is because I was choosing some other kernel. So let me re-execute this now. It should definitely work, right? All right, so meanwhile that thing loads, what I'm going to do here is we have this. If we have to load our data on our MNIST, from our MNIST we have data is equal to, we call this class mnist dot load data. So let's wait for this. And now what this returns us is a train and test, right? So if I can see the documentation here, so you can see here this returns us the labels. Okay, so it gives us X test, Y test, X train, and Y train. So let me quickly copy this and paste it over here. And now once I execute this by shift enter, you will see that we, like if I put here X train, that is, maybe I'm supposed to remove this up over here and change this from lowercase to uppercase, right? Just the X. All right, so let me just put back the braces here and execute this. So now let's see how our X train would look like. So X train dot shape. So you can see we have 60,000 images whose size is 28,28. Now let's see how this images would look like. So in order to see the image, what I will do is we can use plt.show, right? So plt.imshow, and now all I need to do is pass my value here. So it will be X train. We obviously need the 0th value, right? So let me just put plt.show. Okay, so as you can see, we have a number 5. Now you might be wondering where's the label data, right? So let me also give you the label that is present in Y train. So if I put title here, so what I can do is Y train of 0. So as you can see, this is 5. And now similarly, if I put some another value, let's say 300, some random value, you will see it's giving me, it's labeled correctly. And now if you're thinking that this is a color image, it's wrong. It's not colored image. The reason why we are getting this is because matplotlib is trying to convert this. So if you want to prevent this, what you can do is cmap. We can just assign this to gray. So now our image will be in grayscale. All right. So now that we know how our data is, let's now create a model. So what I'm going to do is I'll just give a comment here, creating model. Okay. So in order to create model, if you know a bit of how deep learning works, here we'll be using something called as Keras framework. All right. And the way this works is we'll be having multiple layers, and each of these layers will have, a convolution layer to take up extra features. If we have to reduce the dimensions, we'll be then using filters for this. So let's now see how we can do that. From Keras dot layers, import dense layer. All right. And then we have convolution layer. So this is basically a filter. So con2d. All right. And then we have average pool. Okay. The actual name for this is average pool 2D. And then we have to flatten it. So flatten layer. All right. So this is what we have. And apart from that, we also need a couple more stuff. That is sequential model. So from Keras dot models, import sequential model. Okay. And now what I'm going to do is we'll get on to create a model. So first off, I'll give here a variable name. So model. So this should be equal to sequential. All right. Now we need to add a couple more components to this model. So we'll have model dot add. Now we'll call our convolution 2D. All right. And now we have to give number of filters. So as this is a small image, what I'm going to do is I'll just give a few filters, that is 4. Then the kernel size, that is the size of a filter. Usually the kernel size, first off, it is given in the odd numbers, and we usually use kernel size like 3x3 or 5x5. Totally depends upon what you're using it for. So here I'll be using 5x5, and as this is the first layer, right, we have to specify the input shape. So input shape. So the input shape here is going to be 28, 28, 28, and 1. That's because it's not an RGB image. And finally, we have to give an activation function. We use activation function in order to enhance the non-linearity. Okay. And the one that I'm going to use here is ReLU. All right. So looks cool. So let me execute this. Okay. I think I've done a small typo here. So I'm supposed to just change it to E. And again, a typo here. So now what I'm going to do here is, let me zoom out a bit. We'll create similar such layers. Okay. So as this is just a convolution 2D, after this we'll have something called as average pool. This is done usually to decrease the dimensions. Okay. So model.add. So we'll add average pool, and now we'll just have to provide a pool size. So we'll just put here pool size, and this is usually 3x3 or 5x5, but as is a small image, we'll just give 2x2. All right. So this is done. We are done with one particular layer. Now after this, we'll again pass a convolution layer. So I'll just copy this over here and paste it. And I'll just do a couple changes. Instead of input shape, I'll just replace this by nothing. And then the kernel size, we can just give, instead of 5x5, we can give 7x7 or 8x8. Totally depends upon you. So here I'll be giving 7x7, and then this would still remain the same. All right. So after this, what we're going to do is we have to flatten our model. So model.add. Now we'll add up a flatten layer. And finally, to perform the classification operation, we have to perform dense layer. So model.dense. So it's going to be add. And now for this, we'll add the dense layer. All right. So here we'll have units. So as it's performing a classification task, so units here represents how many number of outputs we have. As we know that the number of outputs here range from 0 to 9. Okay, because that's the numbers we have, right? So we'll give here units as 10. All right. And then we have activation. So the activation that we're going to use is softmax. All right. So let us now compile this. Or before that, let me run this cell, and finally we'll compile it. Model.compile. Okay. And now here we have to give the loss. So here we'll say loss. This would be equal to what kind of loss we are looking for. We can say categorical cross entropy. We can also use something called as sparse categorical cross entropy. If I use sparse categorical cross entropy, then I don't have to convert my outputs into one hot layers. Okay, so I'm going to do that. So it will be sparse categorical cross entropy. All right. And the optimizer that I'm going to use here is Adam. You can use anything that you want. You can use like stochastic gradient descent. Then you have various types that you can use. The best one that is there is as of now is Adam. And then metrics that we want to represent this is by accuracy. All right. So this is done. And now finally we will compile our model. So let me execute this. All right. Maybe we have done a small typo here. So let me change this from accuracy to ACC to accuracy. Oh yeah, it's going to be optimizer, right? So optimizer. All right. So now what we're going to do is finally we are going to see the model.summary. So model.summary. This just basically gives us what we have included here. So as you can see, we have total number of layers as 1446. The number of parameters, it's pretty small when you compare to deep learning applications. Okay, so finally we are going to train our model. So to train our model, we have model.fit. Okay, and now I have to pass just my values here. So it's going to be X test. Then we will take Y test. So it's going to be Y train. All right. Then number of epochs is give 1, because if we give more, it's going to overfit, right? So number of epochs, this would be 1. And the batch size will just give 1. So in one go, it will just take up all the values, right? And let me execute this. All right, so we basically have to reshape our image. So let me quickly get that done as well, okay? So basically we have to pre-process our image. So to do that, we have to reshape it. So let me just quickly show here what I'm trying to say. So if I put here xtrain.shape, so after this, let me add this. So if I put like xtrain.shape, all right, we are getting this, right? Apart from this, I also need to have 1 over here. So in order to do that, what I'm going to do is just put reshape here. So what this would do is like we will just get down here, add one more column or so. Okay, and now we'll take xtrain. This would be equal to xtrain dot reshape. All right, and now we'll pass a tuple value which gives us this thing. Okay, so -1, 28, 28, 1. So if I see the shape now, you'll see here for this you have 1. Okay, so the reason why we are getting this error is because our shape is we don't have 1 present here. Okay, so we have to add this 1. So it's pretty simple. All we need to do is reshape. So we'll just kind of do reshape over here. All right, so here we are getting an error. So let's see what is this error that we have, right? So error here we have is with the shape. So it is expecting dimension 3, but then it received this particular shape. So the problem over here is we're supposed to have 1. Okay, so number of dimensions should be 4. So here should be 1, 28, 28, 1. This has a simple fix here. So what I'm going to do is I'm just going to take this xtrain. I'll just reshape it. Okay, so xtrain dot reshape. All right, so we are going to pass -1 here, and then we want to give 28, 28. That's the image and number of dimensions. Similarly, we'll do it for y values. So let's get x test, and this would remain completely same. So let me copy this and paste it here, and instead of train, it's going to be test. Looks good. So once I execute this, let us rerun this part over here, model.fit. Okay, so for this, what we'll do is we'll rerun this model from start. Okay, so we'll run this from here, 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 here. So as you can see here, now our model is working, and this currently is in a training phase right now. And the way this thing trains totally depends upon your CPU or a compute power. What people usually do is, if they have any machine learning or deep learning model, they would just go down to Google Colab, as it's totally free of cost. Okay, so let's now wait for this thing to train off. All right, so we have now successfully trained our model. So now what I'm gonna do here is I'm just gonna like save this model. And if you think how this works, so let me now show you. Like if you remember, we have a couple of images here, right? So now what I'm gonna do is I'm gonna load this image over here, and then let's see what this image value represents. Okay, what does this model predict this value? All right, so now what I'm gonna do is like import CV2. All right, now with CV2 I can just provide a path, or I can also have something like pandas. Okay, And now what I'm going to do is I want to read this particular image, right? So pandas. All right, apart from pandas, I can just use CV2. So let me quickly import that. So I'll have CV2. All right, and now if I want to read the image, let me just give a variable here, the cv2.imread. All right, and now let me just take any random image, and we know this image is 3, so I will copy this and I'll paste it over here. Copy path, relative path, and then we'll paste it over here. All right, and let's quickly execute this, and let's see what is this image here. Dot shape. Okay, the reason why I'm getting an error is because obviously I'm supposed to give a path like this, and yeah, so it should work now. All right, so now we'll try reading this image over here. All right, so the reason why we are getting this error is because it's kind of unable to read this. So sometimes what happens is, depending upon the system, we have to use different orientation of this particular path. Okay, so let me fix that up here. So let's see how this thing works. All right, so this is not working. So what I'm going to do is, instead of this, we have a test data set, right? So let me say X test. Let's say if I take 0 and if I plot this plt.im_show. All right, so this should show me 7, right? Okay, so this is showing me 7. Now what I'm going to do is I'm going to pass this image into our model and let's see what this thing predicts. So before I can do that, let's say I have to resize it. Okay, so I have to take X, so I'll like test value, then I'll pass here X test. We want the first image dot reshape. All right, now we'll take -1, then we have to, obviously it will be 28,28 and then 1. So if I say test.shape, all right, so as you can see we have this. Now we'll just predict this. So we'll have model.predict class, and now I'm just going to give test value. So you can see here we are getting the value here as 7, right? So similarly, if I take up any random value, let's say I want something like 78. So this is 9, right? So let's see how does 9 looks like here. So what is the value? 78. And as you can see, our model is predicting well. So finally, what I'm going to do is I'm going to save this model. In order for you to save the model, we have 𝐾RAS function, which says model.save. All right. And now what this model.save do is we have to pass a path, and all we need to do is like my model.h5. And now once I execute this, you can see here we'll have an h5 file. All right. So this is how we work and train our model. Now what I'm going to do is, in our next stage, we will get back to our Python and we'll just pass a value like this particular image, okay, to a model, and once it predicts this. So now if I have to load it, we'll use load model, and then we'll just put a model underscore my model underscore a model, and then just dot predict, and we can get the output. All right, so let me now quickly move to my code editor. So let's save this and let's create a Python file here. All right, and the name of this Python file that I'm going to give is, let's say, app.py. All right, and let me quickly get that, open that up. Okay, so now when it comes to app.py, let me zoom in a bit so that you can see it clearly. So first off, let me tell you how we are going to work through here. So what we're going to do is we're going to use something called as Pygame module, and Pygame module, if you know, it's one of the most popular application or a framework to develop games. Okay, so the reason why I'm going to use Pygame is because here we have something called as event loop, which is a constantly running loop until unless we don't close our application window. So that means our window is continuously getting fresh. So let me quickly show you how we can work over here. So first off, we'll import Pygame and then system framework. Then we also need to import NumPy. Okay, and then we have 𝐾RAS.model, import load model. So load model we basically use to load the model, right? So load model. All right, and apart from this, we also will import, or it will be like this, from pygame.locals import star. That is, we are trying to import all the packages. And finally, we need CV2. Import CV2. All right. So now what I'm going to do here is, so first off, what I'm going to do here is we'll initialize our pygame. So for that, we'll have pygame.init. All right. And now what I'm going to do here is we'll have to create a page. All right. So pygame.display. All right. So pygame.display.set. Okay. Underscore mode. And here we are going to pass the name or whatever the size of the screen that you want. Okay. So window size that I'm going to give here is 640 pixels by 480 pixels. It's totally up to you. You can give whatever you want. All right. And apart from that, we can also like have this. So for this, let's give a name. We'll say display surface. All right. And now what I'm going to do is for this display surface, we'll also add some colors. So white in it. So display surface, that's what we have described earlier, dot map RGB. And we'll give here as white. Okay. And this, what this white value over here represents is whatever we type in, right? So like it accepts only white values. So we'll give it here as white. And this would be 255, 255, 255. All right. This looks good. And now finally coming down to caption, let's set the caption for our image. So for this, it will be pygame.display.set caption. So this would be, let's say, Edureka demo. All right. Now finally, what I'm going to do is something that is related to our image. So 𝐓𝐻'Writing, basically I'm using it for my while loop. 𝐓𝐻'Writing. If this is false. All right. And finally, we'll have whatever the numbers we have, right? Like whatever the numbers a person write on a blackboard, we have to take up the coordinates so that I can put them in a bounding box. Okay. So number underscore x coordinate. So this is basically a list, and similarly number for y coordinate. All right. And by default, I'll give number of image as 1. That is image count. So this should be 1. So finally coming down to the event loop. So if you know about Pygame's, event loop is basically an infinitely running loop. Here we can capture whatever input that is being given from the input user, and it constantly refreshes the screen. So this is like while true. Okay, as I mentioned, it is constantly running. So what I'm going to do is we'll capture the event. Okay, so while, or we can use for loop here, for event in pygame.event.get. All right, so basically I'm trying to capture my event here. So now what I'm going to do is if event.type is equal to quit, okay, that is if I close the button. So then what I want is pygame.quit. All right, and similarly I'll use this sys.exist. All right, and now what I'm going to do is if I'm writing, right, so if someone is trying to write, so if event.type is equal to mouse motion and 𝐓𝐻'Writing. So if you remember, we have declared this 𝐓𝐻'Writing over here. So now if this is the situation, what I'm going to do is first off take off the x coordinates. So x coord and then y coord. We have a built-in function here that is event.position. All right. And then finally what we can do is pygame.draw. Then we have something called a circle. And we have to do this on our display surface. So I'll just pass our display surface, and the color I want is white. If you remember, the white is it's basically a variable which is over here 255, 255, 255, and then finally we'll pass our area, that is x and y coordinates. So it will be x coord and y coord, and finally like shape or the size of that and 0. And finally we'll append the coordinates to our, so number x coord dot append. We'll give here as x coord, and similarly for y coord. All right, so this is one thing. So next off, if we have if event dot type, and now 𝐓𝐻'Writing will be true. Okay, so here we'll have mouse button. All right, so it's going to be mouse button up. So when the mouse button is up, we have to perform various tasks. That is nothing but once we are done writing, right, we have to, whatever the values that we have to take it and pass it to a model. But before that, let's also do it for mouse button up or when the mouse button is down. So if event.type is equal to mouse button up or mouse button down, that is, this is going to be down. Okay, so when a person starts writing, then what happens is writing variable, this would be true. And now coming down to mouse button up, so this is a pretty important part here. So now what happens is, first off, we will change is writing to be false, because we all know that this is a constantly running loop. So we'll just update the value first. Okay, and now we'll take the value of x coordinates. So this will be sorted. All right, so number of x coordinate, and then similarly we are going to do it for y coordinates. All right, so now we have to find out the rectangles, right? So for that particular bounding box, so it's pretty simple. So we'll just give as xmin, you can say rect underscore minimum x, and then we'll have rectangle max y. All right, and now basically we'll just find the maximum value which is present over here. So we'll just do max. Okay, and number x coordinate, that is the 0th column here, minus boundary. Okay, we also have supposed to put on this boundary ink, so we'll just give that. So it'll be, just come down here and give a variable. This is basically like padding. Okay, so boundary, so we'll just give here as 5. And similarly, if I come down here, it will be boundary ink and then comma 0. And now similarly for minimum value, so this would, it would remain same. So I just have to take here as minimum value. Okay, and then we'll give here as window size. Okay, so let me fix this up. So here it will be minimum value. All right, and we'll change some arguments here. So window size. All right, so window size x is a variable that we'll be defining up. And then we have number of x chord. Here we'll take the -1 because we have sorted it out, right, if you remember. And then we'll add this to boundary ink. Okay, so we'll have boundary ink. Okay, so now what I'm going to do is we're going to find the rectangle for both even y coordinate. So let me copy this and come down here. So you're going to go here, instead of x it's going to be y, and similarly here instead of x it's going to be y. And now similarly what I'm going to do here is, instead of x coordinate, this will be y coordinate. So, and this would be minus, so this is absolutely fine. And then so for minimum, what I'm going to do is window size y, right? So window size y, and this is going to be y coordinate. So now we have the bounding boxes value for both rectangles. Okay, and now similarly what I'm going to do here is window size x and y. So let me go there on top and give window size x, so it will be 640, and then window size y will be 480. So basically this is this values here. Okay, so now what I'm going to do is we'll create one more list down here. So number record x, and then number record y. Okay, and then we have input img, or I can just put here as image ar, image array. So there'll be np.array. Okay, and now we have something called as this built-in function in Pygame. So it's pygame.pixelArray, and now we'll just give a display surface. All right, and now what I'm going to do is if image save, that is if I want to save the image. All right, and this is basically a variable that we're supposed to define on top. So let's quickly get that done. So we have this, and we'll give the value here as false. So if it's a new image, then what I want is to save it. So cv2.imwrite. All right, and we'll just give here as some value .png. All right, and now we'll increase the count of our image. So image count, so if you remember, we have done that. So this will be plus equal to 1. All right, now finally coming down to predict. So if predict, all right, so this is also a variable that we are supposed to define on top. So we'll give here as predict, and we'll give the value here as true because we want to predict it, right? So if predict, so here we'll have image. So this would be something similar to CV. First off, we have to resize it. Okay, so CV2 dot resize. Okay, so I'll pass my image array, and the size that I want is 28,28 because we have trained our model to be working on that, right? So this is it, and now we have image. So this would be np.pad. So I'm adding padding layer. So I have image. I'll add like 10 pixels. Okay, 10,10, and finally the value is going to be constant, and the value of the constant is 0. All right, and now coming down to like drawing a rectangle here. But before that, let's also we have to normalize our data in our image. So image is equal to cv2 dot resize. So it will be -1, that is the size of an image. Okay, so here we're going to pass the image name. So image, so 28,28, and then finally to normalize it, we have white in it. So if you remember, white in it is 255, 255, 255. So in order to predict, we just have to do model.predict, right? And we have already loaded our model. So I'll give here label as label. So it'll be string, right? str. So now I have labels. So np.argmax, and now we'll have model.predict. So finally I'll have image here dot reshape. All right, so now what I'm going to do here is we'll call a model. Okay, so we'll load our model here. So we'll create a variable called as model, and to load our model we have a function that is load model, and now we are going to just pass the value. So if you remember, we have loaded our model present over here .h5 file. So copy the path here and paste it over here. Looks good. So finally we are done with the predict. Now all I'm going to do is whatever we have predicted, I just have to put that in a rectangular form, right? So we have pygame.draw.rectangle. So now we have something called as display surface. All right, we'll have this red. We'll try to define this. I'll tell you what exactly this is. So red, and then we have minimum and maximum value of rectangles, that is the coordinates, right? So we have first one is rectangle minimum, that is x value, and then we have a minimum value of y. Okay, and then we have the maximum value rectangle max, the minimum, and then if I go for rectangle max of y minus minimum of y. All right, and finally I want the thickness to be 3. All right, so once this is done, we are done with the predict part. So what happens is if event dot type, if this is equal to key down, okay, if this happens, then we have if event dot unicode is equal to n, then what will happen is display surface dot fill. That is to, we are basically here trying to reset our image, right? So black. So black is yet another constant here. So we'll give VLACK. So this will take a tuple value. So 0, 0, 0. So once this is done, we have to do pygame.update. All right, so with this, we have completed our application in Python. So let me now quickly run this and see how this would look like. Okay, so let's run this, run Python file in terminal. So basically now I should get a console. So this is taking quite some time. So let's wait for a minute or two. Okay, so as you can see here, we have got a console. And now if I try to press 8, like if I draw 8, you can see here we are getting this value 8. And now again, if I say 9, right? You know what is happening here is the features. Okay, so if I put this curve like this is a feature of 0. Like if I put something like this, right? So this is 0. So if I put 1, right? So it is representing 2 because we have this curve. As this is a deep learning model, it's more of a pattern. Okay, so now if I have to represent 8, it's something like this. Okay, so it's showing 2, but if I put it like this, 8. All right, so it's all about patterns. Okay, so this is 5, so you can see it's showing 5. And now similarly, if I have to put on some other values, let's say something which you haven't tried, So I think 4, right? So we have 4, something like this. So as you can see, we are getting 4 over here. And now every time I click N, what happens is the board gets reset. All right, so this is basically what is happening in image processing. We basically are trying to create a bounding box and then give an output. This is a very simple example of what image processing is capable of. All right, guys, with this, we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in a comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!